Hello everyone, Teacher Sunny is here. Alright, today, as usual, and in response to some parents' requests, I'll be talking in a bit more detail about thinking skills and mathematical thinking, especially for younger students, especially for those students who are currently in the lower grades. No problem at all, so in the coming November and December, Teacher Sunny will be sharing even more of this kind of educational content. We'll be explaining the types of questions from a more fundamental, logical, and step-by-step perspective, aiming to help everyone better understand the underlying principles. Of course, some people ask, there are many different methods out there, like Olympiad math teaching, and so on, but as everyone knows, a lot of it is really just about doing tons of practice problems, walking through exercises again and again. After having you imitate one problem, you then repeatedly practice similar problems and methods, following the same steps each time. So after doing this kind of practice for a long time, parents, you need to understand that your child's thinking will gradually become rigid and less flexible. Why is that? Because this way of learning is not based on fundamental logic or a true understanding of the underlying principles. The child hasn't truly understood the fundamental principles. For regular problems, there probably won't be any issues, but when it comes to competitions, you might find yourself at a loss, and the child won't know how to solve the problem. Why is that? Because they haven't fully grasped the essential principles. So today, Teacher Sunny is going to explain this set of problems to everyone and clearly lay out the fundamental principles behind this problem. Many people focus a lot on methods, and that's not wrong. Methods are very important, but parents, please remember, how are these methods developed? How are these techniques derived? The secret here actually lies in this. All of these are methods extended from fundamental principles, techniques that are derived from the core principles. That's why understanding the fundamental principles is extremely important. So, if children can grasp as many core principles as possible, then no matter how the question types change or how much the difficulty increases, as long as they start from the fundamental principles, they will always be able to find a way to solve the problem and discover the solution method. Today, Teacher Sunny will use this question as an example and break it down for you. As you all know, let me explain it in detail for everyone. Let's take a look at this question. The eagle distributes food to the chicks, and each time the eagle gives out either 10 more or 9 more. If each time the eagle gives out 1 more or 2 more, the question is, how many chicks are there and how much food is there? So, carefully reading the question is extremely important. In previous sessions, I've shared a lot about this, and I've always mentioned that carefully analyzing the question is a crucial step. So from here, we already know. The scenario in this question is that the eagle is distributing food to the chicks, and there is a specific order in which the food is distributed. This is very important. First, each chick gets 10 pieces, and there are still 9 left over, right? There are still extras left, so what does that mean? So going back even further in time, let's take a closer look at what happened. When just one chick gets 10 pieces of food, a circle is used to represent each individual chick, and the number that you see inside the circle shows exactly how much food that particular chick is able to get. So, in this case, one chick can get this specific amount of food, which is shown by the number inside its circle. So, how many chicks are there? We don't actually know that yet, so we use dots to represent that there are several chicks, and we also draw the very last chick. Before that, it still looks exactly like this. So from here you can see that in mathematics, we try to make things more concrete and analyze them carefully. So do you still have any extras left over here? Although there are 9 extra, and these 9 extras, since each person has already received 10, all the 10s have been distributed, but there are still 9 pieces of food left that haven't been distributed. So when we distribute them again, what happens? We find that in this situation, each chick can still get a total of 11 pieces of food, right? And after each time we finish distributing 11 pieces to each chick, there are still 2 pieces of food left over. So here we're actually using this fundamental principle. What is it exactly? It's a very important and fundamental way of thinking called comparative thinking, where we carefully compare the changes that happen before and after. Then, by comparing the changes before and after we've drawn it out in the proposal and thoroughly analyzed it, we do another comparison. This way of thinking can really help us find a method to solve the problem at hand. Alright, now let's look at the question together. We need to find out how many causes there are, and also a few other important things. So let's look at this part right here. At the very beginning, there are 9 in total. Oh, and then when each one is given 11 pieces of food, basically what happens is that the amount of food goes from 9 pieces all the way down to just 2 pieces. So doesn't that mean that 7 pieces of food are missing from the total amount? That means they were used up, right? Used up. So the difference is the amount used up, which is actually 7, right? We used up these 7, okay? So in the end, there are only 2 left. But where did those 7 go? Those 7 were all used up here, because here 1 was added and here 1 was added, right? There's 1 more here and 1 more here. To be clear, every one of those 7 was used up in this process. There's 1 more here, right? So that means 7 were used up here. With this kind of comparison, we can easily figure it out and get the answer. So how do we calculate the answer? First, we know how many were used in total, which is 9 minus 7. Actually, it's 9 minus 2, the difference before and after. By looking at the numbers carefully, we can clearly see how the total is determined, and this helps us understand the process better. And 7 were used up, so how were these 7 used? It's like this. Each time with each additional answer, it increases by 1. So 11 minus 10. So in this way, we get 7 divided by 1, which gives us 7. And 7 because each one. With each extra division, there's 1 more piece of food. So with 7, it's just enough to distribute all 7 pieces of food to everyone. Point. So if we know there are 7 answers, it's actually quite easy to figure out exactly how many pieces of food there are in total. Alright, we can calculate it using the previous distribution or the later distribution. Either way works, but it's easier to use the previous distribution since it's 10. Okay, there are 7 answers. These young eagles, there are 7 young eagles. Alright, so what about the number of answers? In total, as a matter of fact, there are 10 pieces of food, plus the extra 9. At that time, with the extra, it's 79. So that's the food. Have you learned it? If you have, please give the teacher a like and follow, and remember to use your little hand to share this. Thank you very much.